In this video, we're going to talk about what we call the shape of a distribution. And the shape of a distribution is directly related to the mean and the median of the distribution. So in the other video, we are going to learn how to find a mean and a median. So we're going to talk about comparing those two things together to get our shape. And in general, there are three shapes in a distribution. The first shape is what we call symmetric. And in a symmetric distribution, the mean is equal to the median. And generally, the shape of something that is symmetric looks like this. And what we do for shape is we'll draw a curve over this. And when we look at the curve, we're looking actually at the tails of the curve. We want to see what tail is longer. In this particular distribution, there's tails on both sides, so neither tail is longer, so we call it symmetric. The next shape is what we call when something isn't symmetric or it has a skew. The first what we call left skew, also known as negative skew. And in negative skew, the shape of the distribution looks like this. And here you can see that if you put a curve over this, the tail on the curve is on the left-hand side. And in this particular distribution, the mean is less than the median. And when we talk about negative skew, what we're talking about is skewing the mean. So in any kind of skew, you're going to skew your mean. And we've seen in our other videos that the mean is heavily affected by extreme values or outliers. And then the last type of skew is what we call right skew, or also known as positive skew, because you're positively affecting the mean. And in right skew, we get a graph that looks something like this. And when you put your curve over this particular function, you have a longer right tail. And in this distribution, the mean is greater than the median. And what this means is if you look at these distributions, or if you talk about the frequency of each bar, and remember, frequency in a histogram is always measured by the height of the bar. Well, we can think of these things as, let's say I gave you a test. And on that test, in this particular class, most people scored around the center value. And you had a few people score very high and a few people score very low. The highest of the highs was very small. The lowest of the lows was very small. But most people are around the center. Here, in this particular test, very few people scored low, and a lot of people scored very high. So think about the mean of that distribution. Will it be high or low? It'll be high because most of the people are scoring high, right? And the mean should be high like that. But what happens though? These very low people right here, what do? They skew the mean towards their direction. So they actually bring the mean down from where it should be. And in a left skewed distribution, it turns out that a better representation of the typical value is the median, because the median will sit in this peak, will sit in these areas around the peaks, while the mean will sit towards the tail. In a right skewed distribution, here a lot of people scored low. There's a lot of people scoring low in this distribution and very few people scoring high. Well, what will happen to the mean? The mean should be sitting somewhere over here. But because of these high scores, they're going to skew the mean to the right in their direction. And because of that, the median, again, is a better representation of what the typical values are. And generally speaking, here's how it works. Your skew will always take place. The skew always takes place in the tails. So that means that in a left skew distribution, your mean is in the left tail, while your median takes place in the peaks. And in a right skew distribution, your mean is in the right tail, while the median here is in the peaks. And when we start to talk about these distributions or describe these distributions, what we're looking at now is If I ask you for a typical centering value, there are two centering values, and they are the mean and the median. They are the mean and the median. In a symmetric distribution, the mean and the median are equal. So in a symmetric distribution, then, we're going to always talk about a mean. And that's because the mean takes into account every value in the data set. To find the mean, you have to add every value up and divide by the total. And in a symmetric distribution, the mean will always sit in the middle along with the median. So if we can report the mean, we always want to report the mean as a typical value. However, when we move to skewed distributions, the mean is not very representative of the entire population. And that's because we're skewing the mean. So when we report a typical center value, and again, a center value is either the mean or the median. In a skewed distribution, we always talk about the median. So if we have left skewed or right skewed distributions, we're going to talk about their medians, because those are where your typical values are occurring. So here's an example. And in this example, it says we looked at 12 households, and economists looked at 12 household comes, and they found these things. And for this particular distribution, we've already found this in the other example, the mean was equal to $56,000, $56,840, and the median was equal to $47,000, or $47,799. And remember, we found that already from the previous example. If we were the economist, which value do you feel is more representative sample? Well, look here at the mean and the median. The mean is a lot bigger than the median. So we know our mean already. Our mean is greater than the median, which tells me that that this distribution is skewed. And remember, if the mean is greater than the median, it is skewed to the right. We have right skew. So this tells me this is a right skew distribution already, just because of knowing the mean and the median. I can compare those two. Because it is right skewed, and because it is skewed, the more representative value of the sample is going to be the median. Is the median. Why is this value more representative than the other value? Well, because it's skewed. And what I'm really asking you is, what particular value is skewing it? Well, we know this value right here, this very large value. And if you look at the graph of this right here, you can also see, here's the graph. You draw a curve of the graph, look at this skew here. This one value, this extreme value right here, it's going to be referred to as an outlier layer, but right now it's an extreme value. It is pulling the mean. It pulls the mean and makes it look a lot bigger than what it really is. So because of that one value, we should use the median. So why is this value more representative than the other value? Because the distribution is skewed. And it's skewed by the outlier. All right. So that's how we find the shape of a distribution, and that's how we use the shape to talk about the mean and the median.